AI is changing the world. It can write code, book flights, analyze financial data, and even automate entire workflows. But what happens when AI goes rogue? Without access control guardrails, AI can't be trusted. AI is not human. It doesn't understand context, risk, or responsibility. It will execute any request unless you set the boundaries. That's why AI needs structured access control, rules on who can ask what, which data can be accessed, and what outputs are allowed. That's where Permit's innovative 4-parameter framework, developed in-house, comes in. There are 4 different problems that I want to touch on today that we can experience when working with AI agents. And the first one is called prompt filtering. Unfiltered AI requests can lead to misuse, from generating harmful or misleading content to automated spam and bot abuse. If something like this is left unchecked, an AI system could be flooded with irrelevant or malicious queries, degrading performance for legitimate users and even being manipulated. It's about keeping AI responsive, responsible, and reliable. Now imagine an AI legal assistant is being asked to summarize an entire book. The user doesn't realize that having a long input equals a very high cost, and the company then gets hit with a massive AI processing fee. That is not what you want. And a good solution to that is working with access control to make sure your prompts are secure. Things like being able to block malicious inputs, like SQL injections and jailbreaking attempts. Limiting the prompt is also important. You can enforce attribute-based access control restrictions on things like the length of the content, the type of the content, and the user roles. And then you can also provide real-time enforcement. Things like filtering prompts before they even reach the AI. Now, the second problem that we face is called RAG data protection. Now, let me explain. Now, AI doesn't inherently understand the difference between different types of data. It simply retrieves and responds based on the information available to it. At its core, an AI model generates answers from data it was trained on. But when augmented retrieval, or in other words, RAG, is introduced, the model isn't just pulling from its pre-trained knowledge. It's dynamically fetching external data to enhance its responses. Now, this creates a bit of a challenge. How do we control what data is retrieved and shared? Without safeguards, AI could surface confidential, proprietary, or even personally identifiable information without context or restriction. Scary, I know. Worse, once this data is included in the response, it can be exposed to users who were never meant to see it. Let me give you an example. A financial advisor using an AI-powered chatbot requests investment insights for their clients. Now, without proper data control, the AI retrieves unrestricted financial records. Things including tax history and maybe private banking details, regardless of whether that advisor is authorized to access them or not. Yes, things can get bad. But a solution to problems like this is having granular access control, setting up definitions of who can access what. You can do fine-grained filtering and restricting data before and after the retrieval, and you can also offer seamless AI framework integration. And in this case, you can secure the sources where that data is taken from, like vector databases and other knowledge bases. Now, the third problem we face when we work with AI agents is something called secure external access. Let me explain. While automation can enhance efficiency, because that's essentially what we all want to do as software engineers, it also introduces serious risk. Let's assume that an AI system has unrestricted access to external services. It could then make unauthorized purchases, schedule unintended meetings, or even transfer funds without proper oversight. A simple misinterpretation of a request, which is very possible, or even a maliciously crafted prompt could lead to unintended actions with real-world consequences. Access control is key. AI should only interact with external systems with well-defined access control. ensuring that every action is validated, authorized, and auditable. Let me share an example. An AI-powered travel assistant is connected to a corporate credit card. You can see where this is going. Due to missing restrictions, it books luxury hotels for anyone who asks. That is a big pain for a company. Now, how do we create a solution for this? Well, again, it's quite simple. First of all, you need to introduce something called identity-based permissions. So you then restrict AI's external access based on the roles that it might have. Then you define the allowed actions that it can perform. You specify which API calls, transactions, or operations are allowed for it to work with. And then you can also introduce user-approved transactions. You can require some kind of human approval before an AI executes those actions. And then you're really keeping it much, much safer. Now, the fourth and final part is called response enforcement. Now, AI-generated responses can contain misleading, harmful, or legally risky content. Without access control and safeguards, AI may generate misinformation, and I'm sure everyone here came across this. It can even expose private data, leaking to some very, very serious compliance violations. In high-stakes fields like finance, healthcare, and law, inaccuracies can have severe consequences, while unrestricted AI actions can result in legal liability. Now, for example, someone asks an AI, "Should I invest in Dogecoin?" Well, the AI gives financial advice without providing any sort of disclaimer and opening the individual to liability issues. The individual invests in Dogecoin, all their money, and then they lose it. Who is responsible? Well, if you didn't give a disclaimer, it's a bit of a dodgy situation. Now, there are ways to fix this. First of all, we can provide something called output filtering, which means we're looking at the output and we're blocking sensitive or inappropriate content from actually arriving to the user. Then we can introduce things like compliance policies. We can enforce regulatory and ethical AI responses to make sure that, obviously, it doesn't give a very weird answer. And then we can also introduce custom role-based control, which means that we can essentially define who can see what in the AI-generated results. Some people might get the response, others might be restricted to not having it. This is all great and amazing, and as part of this, Permit actually introduces some pretty incredible integrations that you can use to make all of these restrictions. Permit is designed to secure AI workflows seamlessly. It integrates with Pydantic, LangChain, Model Context Protocol, and LangFlow to give developers absolute full control over their AI agents. Now, AI is powerful, but without access control, it is quite dangerous. Want to lock down your AI while keeping it useful? Check out Permits for Perimeter Framework today.